this is the whole tray for TSQ, and that's the most critical part. For ISQ, it's much easier because ISQ, you can imagine that we take the Q2, Q3 off, and the EM diode and the EM and the backside, right? So you can take the diode and EM from the top, and the most critical alignment issue is between Q1, Q2, and Q3. For ISQ, when they're out, there's a negative 10 kV diode there, so all ions can go out quickly to the detector system. But for TSQ, the ions should go through. There's no source cartridge inside. I volume, lens 1, lens 2, lens 3, IF lens. This is the S lens. Then it goes Q1, Q2, Q3, then to the detector. If there's any section the alignment is off, you cannot get the spectrum, right? So that's the most critical. So from the training presentation, we don't recommend you clean the tray because of the source cartridge design. The first part of S lens is IF lens, so we take data out and clean that. But with the customer's application for years, especially for some instrument more than 5 or 10 years, especially for this some high heavy matrix or high volume point matrix, so you can see some condensing and the part of the S lens, either the Q1 burn mark, very clear burn mark. So you will lose your sensitivity intensity. So in order to save the cost for customer, we have to clean that. When you want to clean that, you need to take it apart, take everything apart. So from the source, exactly the same as ISQ. So from the front part to here, exactly the same as ISQ. But there's a TSQ and Q2 and Q3. And the bottom side, you can see that, make sure all these wires leave the original position. These are hard and you do not overbend it. And do you know what's this for? Collision cell, and there are 2 pairs of collision cell. Collision cell is also a quadrupole, but we don't apply raw DC on it. We IF only, and we also apply energy with argon inside, with applied energy to hit the precursor, to break the precursor to daughter ions. Right? So there's a argon inside, and with IF to let the ions go through the Q2 and apply energy to the collision cell. We also apply DC gradient there. From the EVO side, we apply the DC gradient. There's a set of resistor and a plate, so we can accelerate the ions transfer in Q2 because we apply different voltage at the entrance and the exit of the gradient. So we set of the I can show you a picture later because we don't want to break that, take it apart. There's a set of resistance and the voltage decrease after each resistor, and there's a potential, we call potential, DC potential, so ions can pull, so ions can go faster through the Q2. Q3 exactly the same as Q1. Okay, so the critical is easy to take it apart because T20 is fine, so we can use T20 to unscrew. For these screws, I mentioned that for these screws, you need put it at a clean place. Make sure you do not mix these screws and other screws for covers. Make sure all items inside the vacuum chamber is clean. Keep it clean. Yeah.
แล้วก็ container 放 screw
This is the exit lens for Q3. This is the Q3. There are four rods. You can see here. These wires connected this set of rods, right? You can call LOB, and these wires make this set of the rods at the same voltage. So there are two sets, we call two pairs, A and B. So we don't know which one is A, which one is B, but these are connected. These are connected, but these two, the voltage polarity is different. Okay. Before you take it apart, we recommend you take pictures for each item, because make sure we don't want to like this, because the factory tested the direction and the side. So we don't want to. You also can find some numbers here. Let me see. I cannot see it. Here, yeah. You can take the picture here from then you can put it back with the original direction. Okay. Again, do not take this ceramic out and take each rod to clean it. We only clean the entrance part with we don't recommend aluminum oxide, because the particle is easy to be condensed inside that. It causes problem. Sandpaper is fine, with a very fine sandpaper, and clean. And you can sonicate the quadruple, but do not put it in the bottom of the beaker. Hold it and solvent here. You can sonicate like this, or you can flush with the solvent. But first, you need the solvent. It should be very high purity. And then you need to purge with nitrogen. Make sure the solvent be purged immediately after the clean. Otherwise, the solvent, when the solvent dry, you can see some marks of the solvent. It's not good. Okay. Normally, Q3 needn't to be cleaned too much, because most heavy burn mark is the entrance of Q1. And Q3 you can purge with nitrogen. Make sure after the clean, you can see that. Make sure no any dust, no any particles inside. You can like this. Make sure it's clean. But this one you don't care. But at customer side, make sure it's super clean. Okay. Otherwise, you will lose your sensitivity and got a lot of noise. I saw that the customer has some small fiber in it. When the IF applied, the fiber will be standing, and it looks the spectrum looks ugly, because high voltage IF and DC apply on the roll. Okay, this is Q3. Before you take it off at the customer side, I recommend you take pictures before you take it apart. Okay. These are Q2. You can see that there are two connectors here. This for ground, right? This for ground, and these are applied IF to let the iron kind of iron optics, and these are two lenses here, DC lenses. This is the Q2 entrance lens. This is the Q2 exit lens, or you can call it the Q3 entrance lens. Yeah, same for focus irons. So you can see the hole is very small. So make sure the irons focus in the center of these holes. Otherwise, the irons will hit the lens and cannot go through the Q2 or Q3. But we don't want to take it apart. You can see that inside there's a DC gradient. And we don't do anything here. Again, to put these all items in a clean system. In Europe, one FSC struggled around several months for one TSQ because of the lower intensity and repeatability. Finally, instrument returned back to factory. We send a new instrument for customer. Then the factory run failure analysis and take it apart from there's a small fiber inside the lens 2. I don't know why the fiber can go inside the lens 2 and cause somewhat short of the lens 2 to the Q2. But when the instrument is off, you measure that it's not short. But with the high voltage applied, it caused the issue. Very small fiber. I saw the picture, but if there's something inside, it's a disaster because you don't know how to take it off. Okay. Then this is Q1, so easy to take Q1. This is for the Q1 entrance. You can see some burr marks after the application. You get burr mark and the inner side of this each rod. So that's the most difficult part to clean. You need to make sure it's clean and flush it with solvent and water to clean it, and then sonicate it with. Finally, you need to clean with methanol. High purified methanol is easy to get and dry it. Do not let any particles reserve inside, and you also need to check that. This one is. I saw only one customer take it apart and call for service. Yeah, that's the only occasion I was heard reported that. So it's interesting.
Customer took apart.
Yeah. Customer cleaned each rod. Then he cannot put it back. Call for service, please.
Very expensive.
Yeah, so they ordered one. Very expensive. And all these wires are orderable. They are spare parts. In case you break the connector here, you can order this one wire, but you can take a picture to the shape of this. Make sure you don't want to install the wrong direction. Okay, because all the connectors on the left side. And then you can, when you clean the Q1, I recommend you clean the S-lens at the same time. So that's the critical part. We can take it apart. I recommend each one have the chance to take it apart and reassemble. You take the time because that's the only chance for them to hands on this tray. Yeah, it's not easy. In factory, there's a specific room, clean room, to test the tray.
You have the alignment tools also.
Yeah. There's special alignment tool, but in field we cannot. So we use our own experience. Maybe not perfect as a factory, but at least it works. So I think there are 30-40 cases in China, FSC clean the cord. I haven't heard any issue. But maybe the resolution intensity will lose a little resolution, but at least it works. Otherwise, the customer need to order this. Yeah. With these 4 screws, we can. There's another. This is the lens for the wire for the Q1 entrance lens. We need to unscrew this one. Small flat. Yeah, thank you. For these screws, do not use big one, and it's very easy to strip. So you need. And remember the path we need to put like this way. This is the S lens. S lens. When you put the source cartridge in, the IF lens will put inside of this. I don't know how to say that. This part, and connected here. So IF lens is part of the S lens, or there are several names for this part. S lens, iron guide, or pre-filter. So different name, but for same part. And it's also a quarter-ball. There are 4 pieces. 1, 2, 3, 4. And it's also a quarter-ball. You can see that 2 pairs. There are 2 pairs. The meter.
Multimeter.
Yeah, multimeter. So you need to check that. Make sure they are contact together, and they don't. These 2 pairs should not contact. And this iron guide is connected, fixed by these 2 T10. Yeah. This is the Q1 entrance lens. So the position is fixed by the Q1 entrance lens. Thank you. If you don't want to break it, it's also fine that you just clean the maybe two persons work together. One hold that, one clean that, and sonicate that like this way. So you don't want to, because here is critical. Because when you take it apart and put it back, this lens is very close to the quarter ball. It's easy to short. Yeah. I want to take it apart because that's the chance. Originally, this is a brand new tray. It's working, but I supported both two are got arcing, and the quarter board doesn't work. So I took the quarter board for customers, and now it's only for training material, training tool. This tray cost a lot. I don't know the price here, but in China it costs more than 20,000 US dollar. Okay, you can leave it, do not take it apart. This way. So normally we don't take it apart.
So the entrance lens for Q1, no cleaning.
Normally you didn't clean that one.
So just clean the S guide.
Iron guide and Q1.
But you said when sonicate, because I saw some ceramic here, so just the tip
Yeah.
sonicate
Because,
before the
like this way. The ceramic here and it's isolated 2 pairs, right? Because make sure they are not short. So just like this way, you hold.
No, but until
Yeah.
the ceramic should not touch the solvent.
Yeah.
Okay.
Ceramic should not. So you just hold it this way to sonicate it. All bottom parts are metal, so it's fine. Okay. And this is the iron guide, and you can also these are 2 heaters, the source and optics heaters and sensor. You need to make sure it's tightened, because these 4 screws need to be well tightened. And these are, you can also, because you haven't the chance to tighten this. These are they're also ceramic here. Sometimes this ceramic could cause broken. When it's broken, the problem is because this is hold the repeller. If it's broken, this is ground, so the repeller voltage cannot be applied because the repeller will short to ground. So if this ceramic is a orderable part, it's a spare part, so you can order that. Make sure it's okay. There's another ceramic here you can see. So hold that plate, this plate. When you twist the source cartridge, the repeller just stay here. So I don't want to take this source part apart. If you replace the lens plate here, sometimes the lens plate, the ceramic goes broken. If that's broken, you will lose your intensity. You can get some spectrum, but the intensity drops. And you can see that whether it's break from the right side, you can see. That's it. If you want to replace that one, you need to unscrew this one and yeah. There are three wires. Here you clearly marked. You can see here lens 1, lens 2, lens 3. This is lens interface board. You can clearly find the position of these wires. Okay. So what do you need to clean? Source cartridge, iron guide, Q1. Or Q3 normally we don't clean with solvent, just purge with nitrogen. For Q2, nothing to do because it's almost closed section. Only two small holes. So nothing to do. Make sure it's clean. You know. It's difficult. It's easy to take it apart. It's difficult to put it back. Yes, that's very critical. When you put it back, when you clean that, you need a big aluminum foil. When you sonicate, you can put another aluminum foil to cover that. Make sure it's no dust drops inside. Okay, make sure all is clean. When you get everything is fine, clean and purged with nitrogen. And R&D also recommend do not purge with nitrogen at dirty conditions. Otherwise, because when you purge, there's the path, circulation path. All the dust will be sucked inside the portable. Make sure all the lab is clean. Okay. So that's the reason in factory there's a clean room to handle this tray. Special room, not in the final test. Yeah.
So then for the Q2, can we purge through the?
No, cannot.
Also
because, because here, the only small. How to purge that?
Just the
because you cannot purge it. When you purge it, there's something inside. You cannot purge it out. There's only two small holes. Leave it. Again, this piece, and this piece are spare parts. You can order it separately. We made several cases that with some problems, this core got arcing, especially for some CIB problem. When the instrument is turning on, all high voltage applied to the cord. So it got arcing and it burned the whole rod. Then the cord doesn't work, no signal. We have to replace the cord board. Yeah. I think I have got two or three reports about that. These are very expensive spare parts. Yeah. When you replace a new cord board, you need after the cord board replacement, you need in the manual tune to recheck the eye frequency because different cord board the frequency, the dip is different. Okay. Then you also need to manually check the imbalance, everything, to run the whole tune from the initial tune because the portable is different, so everything need to be optimized. Okay. When you put it back, let me see. I have a so this plate hold the iron guide. This way. Can see? This way. Then put it in. Then you tighten this to T10 screws first to fix the position of iron guide with the Q1 entrance lens. So if you are not confident about that, you can keep this hole as a section. Hold that and clean it. So you don't need to take that apart. Okay. Okay. So this is section. That's the plastic part. Hold the position of the iron guide. Then you need to make sure the wire goes through here. Okay. Like this way. Then the most critical part is here is the ceramic. This is the ceramic. and you need to put the front part of this iron guide go through into the ceramic, and here this is the adapter. Make sure the ceramic and adapter fully aligned and there's no big gap. That's the most critical part for that. This way. Okay, you can see like this. From the top, you can see that there's no big gap. Don't like this way. Here, you need it. This ceramic sometimes I've got that it's fragile, and if there's a small piece broken, you can still use that because it's a big ceramic, but it's also a spare part. You can order it, and you can adjust the position of these 4 screws a little bit to optimize the alignment between the ceramic to this SLS, because we have no special tool. In factory there's a special alignment tool, but in field we have to use our eyes for that. Sometimes some engineers like to do this way, so we can. Normally, when you clean tray, especially for TSQ, we recommend 2 engineers work together. It's better.
So if you want to just to clean the Q1, right, the steps is to disassemble everything from Q3, Q2, Q1 onward.
Yeah, disassemble from the end.
Okay.
But if you don't need to, if you don't want to clean the SLS, you keep this stable. But if you want to clean that one, you have to. Even you just clean this one, you also need to take
Remove
everything from the back. Yeah. That's the most critical part. And there's 2 long screws. We don't recommend you tighten it too much, because this screw, these 2, there's another one screw here. These 2 screws align the different components and the source block. So if you tighten too much, when heated, it will expand. Okay. There's another tip. Some engineer like this way, hold like, but we do not let these 2 hold that like this way. Okay. So we need 2 engineers. One hold this one, and the other one. Yeah, thank you. The other one. This way. Because they are straight and hold this shape, fix the position. You cannot rotate like this way, right? You can install like this way, but the wires and the right side, all these wire connectors and the left side. So you can do this. Okay. Then we install Q2. So which one is front? This one. And which one is which direction the left? This one. Because this is the ground. So before you take it apart, take several pictures. Make sure you understand the position of each component and the wire's direction. Okay. So the Q2 hold the Q1. fit that. Okay. So do not tighten all these screws, because put it in, but you do not over tighten. Then you need to optimize a little later. Yeah. So for this one, you need to.
Anh có video của pause the function.
我聽不到有意外，
Uh-huh.
歪了。
有咩 No, then two separate video already. I think that was stop.
OK，
这个 company 讲，
对，它没有放到这个最里面去，它必须要fit the end。
这后来我帮忙 share drive share， and you can share with them. I share with my team.
做一
这边 pause。
对啊，现在是 OK 的，对吧？When you put it in, theoretically, you can rotate a little bit, but it doesn't matter. Because when the field is how to say that, centered field, so it doesn't matter. So this part, I think, is the most difficult part for FSE to handle with the TSQ. So be patient. Do not be in a hurry for this one. Okay. So because this portable, it doesn't matter. We can take we can treat it easily. But at the customer side, do not break anything. Otherwise, you need an expensive spare part. Okay. So we can put it like this. This way. This is the last piece. This is the wires for the exit lens. So you can put it back, or you can put it like this way. So I want to show you different.
那个在下面。
哪个？
这个。
反了，对吧？这个这样，这样。OK， 好吧。Okay, then the tray is almost, but make sure here, again, you can optimize the here a little bit, but to be honest, this one looks not good. You can see the gap here. Right. So you can put it this way to optimize. Now it's fine because all screws are in. So position of 2. It's not so bad. 我是远视眼，看不清。
还是很大。
还是有点大。So you can hold it, please. Thank you. So you can loosen it a little bit. Because sometimes, because this tray, FSC using too much, this plate is a little bent a little bit, so that should be critical. If this bent, so you cannot get a perfect alignment, because the source position is a little bit off. Because I will note that some engineer in Shanghai they played with this part and. Okay. You can still see some small gap here. Yeah, here. Not perfect. Yeah, right. But in field, you cannot get the position alignment like factory. So okay. So we go through the procedure. Okay, see here. When you install that is better, right? Yeah.
But tightening these two alignment doesn't
No. When you put all this in and the source cartridge in, it should be better. Yeah. These two pins we don't tighten too much. Yeah. So it will be better. Yeah, it will be better. Yes.
L shape.
Yeah.
L 的 T20.
Okay, you can see here. Like push this way is better, much better, right? So, but you can also slightly optimize. Thank you. Slightly optimize that one. Okay, we just go through the procedure. So after you alignment, you tighten this. Make sure that it's fixed. Then, so it's easy for ISQ. For ISQ, the only trick is here. For TSQ, you need to make sure whole alignment. Yeah, vertical 会好一点，但是我就这样。
vertical 所以它 gravity
对，往下的，所以 vertical like this. So, but you need 2 people. Okay, much better. Then there are several wires need to reconnect. Here is for the Q2 exit lens at the Q3 entrance lens. Okay. In the bottom. This is for Q3 exit lens. Okay. This is for Q2 entrance lens. Okay. And because we need to also reconnect this one to the list interface board, this one, okay. Then after the reinstall, you need to use meter to check. Okay. For example, you can check here to here, make sure it's isolated, right? And this block. Yeah, this is ground, it's fine. But should make sure the repeller is fine. And these two pairs should not ground to ground, and these two pairs should not ground, and these two pairs should be connected. Right. And the Q1 entrance lens, you can connect here, then check here. Okay, it's much easier. Should not touch each pair of the quad. And also the Q3 X lens. Okay, it's fine. Q3. Q2. Yeah, there are two pairs, right? Here. This one. Okay, make sure there's no short. Then you can put it back to the instrument. First, you need to take the transfer line out and put the tray in. This is the guide pin, push to the end. Normally we put from a little right side. Then because we need to let all these wires goes in correctly, and then put it in position 1 guide pin. Here is the second one to hold the position of the tray, and you need to make sure the transfer line goes in, and there's a small this 6 screw for the transfer line, right?
So this cable, right, if you
Oh.
put in, you can put this way.
Yeah.
Twist, let it, this two cable twist a little bit. So it will not go
Tangle with the
tangle
chassis.
with any.
Yeah.
So it's easier for you to go in to push inside the middle.
And this for Q3, and this for Q2. The Q2 IF comes from the rear IF.
Oh.
The rear IF board supplies IF for Q3 and the collision cell. The front IF supplies IF for Q1 and I guide. So if you have some error at collision cell IF, you need to think about the rear IF board. Okay. So these two from front, these two from the rear. Okay. That's the basic procedure. But on customer side, you need to be more cautious that do not contaminate everything. Gloves, ceramic, aluminum foil, and the clean room purged with and all the solvent beaker should be super clean, because this is the most critical part inside the vacuum chamber, right? Okay. So I think we can 3 pairs, 2 persons for each group. So you need practice, okay? Because